Hey everyone, in this session we will explore adaptive boosting or AdaBoost. AdaBoost is a very popular ensemble learning technique. It combines multiple weak learners to create a strong classifier. AdaBoost follows boosting technique of ensemble learning, where we use weak learners sequentially. Here, as you can see in this picture, our training dataset will be fed into model 1 and the records which are misclassified by model 1 will be fed into model 2. Similarly, the misclassified records of model 2 will be fed into model 3 and so on. If you are not aware about boosting technique of ensemble learning methods, I have a dedicated video for it. You can watch it from this same playlist. Let's understand why AdaBoost is very popular among machine learning communities. There are a number of advantages of AdaBoost. AdaBoost is easy to implement. It is not prone to overfitting. AdaBoost implicitly performs the feature selection. So as a machine learning engineer or data scientist, we do not have to identify the important features from the feature columns. AdaBoost does it implicitly. It can also handle imbalanced dataset. However, there are some disadvantages of using AdaBoost as well. Remember, AdaBoost is very sensitive to noisy data and outliers. So, if we have noisy data and outliers in our dataset, we will avoid using AdaBoost model. In this session, we will first understand how can we apply AdaBoost for a classification problem. And then finally, with an example, we will see how AdaBoost works internally. Let's understand how to implement AdaBoost. From sklearn.ensemble, we can import AdaBoost Classifier. Remember, apart from classifier, we have AdaBoost Regressor as well, what we can use for regression problems. But in this session, we will concentrate on the classification problem. Hence, we can import AdaBoost Classifier from sklearn ensemble family. Once we have imported the classifier, we can create the model, and while create the model, we can customize some of the hyperparameters. As a machine learning engineer or data scientist, we use different values of hyperparameters and find out the optimal hyperparameter values, which is also known as hyperparameter tuning. If you are not aware of it, you can watch my previous sessions where we have discussed about hyperparameter tuning in details. Model.fit is a method using which we can train the model. Remember, fit method takes the training data as its input and train the model. Once we have well-trained model, we can predict the target value from test columns. In other words, we can provide some unknown feature values in order to predict the corresponding target class in case of a classification problem. Model.score gives us the accuracy of the model. Without wasting time, let's jump into Jupyter Notebook where we will write some code to understand how can we implement AdaBoost Classifier and classify iris flower species using iris dataset. We are now in our Jupyter Notebook where we will write some code to implement AdaBoost model. Initially, we are importing all the necessary libraries. Pandas used for data preparation. From sklearn.ensemble, we can import AdaBoost Classifier. We will be splitting the entire dataset into test data and training data. Hence, we will be using train test split method of sklearn.model selection. We will be using the sample dataset what we have within sklearn library called load iris. We will be also plotting the confusion matrix. Hence, we have imported it. Seaborn is a library using which we can visualize the data. Matplotlib also does the same. Pickle is a library using which we can save the trained model so that next time we don't have to train the model, we can directly load the model into our primary memory and predict the classes in case of classification problem. Let's concentrate on the data preparation part. We are loading iris data from sklearn.dataset. If you see, data has a number of directories where data will have all the independent variable columns. Feature names will be the column names for independent variables. Target is nothing but the target variable or the dependent variable. Target names will have different classes. In this case, for iris dataset, it will be the iris flower species. We are creating features data frame. Let's understand what we have within features dataset. We have sepal length, sepal width, petal length and petal width. Based on these values, we will be predicting the class of iris species. Let's see what is there within target data frame. We have corresponding species for each entries in our feature data frame. Species can be 0, 1 or 2. 0 means setosa, 1 means versicolor, 2 means virginica. These are the three different iris flower species name. So based on sepal length, sepal width, petal length, petal width, we will be identifying the iris flower species. That is our problem statement. To accomplish the same, we are first splitting the entire dataset into xtrain, ytrain, xtest, ytest with the help of train test split method of sklearn library, where test size is 0.2. That means 80% of the data will be in the training dataset and 20% of the data we will keep aside for testing the model. Once we have data prepared, we can create the AdaBoost model with the help of AdaBoost Classifier constructor. This constructor also takes n_estimators. This specifies the total number of weak learners will be used for our classification problem. The learning rate is a hyperparameter that controls the contribution of each weak learner to the final combined model. The default value for learning rate is 1. Using model.fit, we will be able to train the model. Now, as we have trained model, we can evaluate the score or the accuracy of the model. Remember, while evaluating the score, we have to pass the test dataset. In this case, our model accuracy is 86% or nearly 87%. Let's understand how can we plot the confusion matrix for these predictions. We are evaluating y predicted with the help of predict method, which takes the test independent variable data. Once we have predicted values, using confusion matrix, we can plot actual value and the predicted values. We will be using seaborn heat map for the same. In this confusion matrix, it is showing predicted values in the x-axis and actual values in the y-axis. This 2 is indicating that there were two predictions from our model, where our model has predicted the iris flower species as versicolor, but in reality the flower species were virginica. These were wrong predictions. Similarly, there were two predictions where our model predicted the iris flower species as virginica, but in reality they were versicolor. And as our model has done few of the misclassification, that is the reason its accuracy is not very good. It is only 86%. Once we have trained model, with the help of pickle library, we can serialize the trained model and save it in our secondary memory for further use. Here we are creating a file and we are saving the AdaBoost model which is already trained. As and when required, we can use pickle.load to load the model and start prediction. We don't have to retrain the model again. That's the benefit of saving a well-trained model into our secondary memory. With this, hope you have realized how can we implement AdaBoost model for a classification problem. Now let's understand how AdaBoost works internally. To understand the steps we have defined here, we have taken a small example. So we will go through each and every step and understand how it is getting applied in this small example, so that you will be able to understand how AdaBoost works internally. So very first step is initialize a weight for each row, and the weight will be 1 by n. where n is the number of records. Here we have only 5 records, hence 1 by n will be nothing but 1 by 5. In step 1 we will be adding weights for each and every records we have, and these weights will be exactly same to start with. So each record will get 1 by n as its weight. Together if you add all these weights you will get 1. Once we have initialized the weight, we use by default decision tree with depth 1 as our weak learners. The decision tree with depth 1, also known as decision stump. These are nothing but decision stumps, where if you see we have tree but depth of this tree is nothing but 1. In step 3 we choose a stump with lowest entropy. Entropy is a measure of impurity or disorder within a set of data points. If you are not aware of entropy, you can watch my decision tree video for details. So what AdaBoost does internally, it creates different stumps with different feature columns. For example, here if we are taking temperature as example, temperature high will be the node, and if the temperature is high, then there is a chance of rain. If temperature is not high, there will be no rain for that day. This is a single stump. In this way, AdaBoost creates a number of stumps and choose the stump with lowest entropy as its initial model, which is nothing but a weak learner. Let's assume in this case our AdaBoost has chosen this stump where outlook is cloudy. If it is yes, then the correct prediction is 2, incorrect prediction is 1. You can check it from this data set as well. If the outlook is not cloudy, always there will be no rain, and hence the correct count is 2 here and incorrect count is 0. In this way, AdaBoost will identify the stump which has lowest entropy. Once it has identified the stump, it will evaluate total error for that model. Total error is nothing but the sum of weights of misclassified rows. In our case, let's assume that our model has misclassified this prediction. That means the total error will be 1 by 5. Once we get the total weight, we will evaluate the alpha or say of a model in final prediction. This is a very important parameter to evaluate. Alpha is nothing but the say or the contribution of a model in the final prediction. The mathematical equation of alpha is something like this: 1 by 2 log base e 1 minus total error by total error. For our example, the alpha for our model will be 0.69 because total error in our case is 1 by 5. Next step is to upsample the misclassified rows. Our target is to push these misclassified rows into our next weak learner. Hence, we are upsampling the misclassified rows by increasing the weightage, and model will reduce the weightage of correctly classified rows. And finally, normalize the weights in order to keep the sum of weights as 1. The mathematical equation for new weight will be something like this. New weight for misclassified rows will be current weight into e to the power alpha. New weight for correctly classified rows will be current weight into e to the power minus alpha. Using these two equations, we are making sure that we are enhancing or increasing the weight of misclassified rows and reducing the weight of correctly classified rows. In our example, the new weight for misclassified rows will be something like 0.398. New weight for correct classification will be 0.1. Once we have this, we will be updating the new weights here. All the correctly classified rows will get 0.1 as its new weight, and the misclassified row will get higher weightage, which is nothing but 0.39. If you add them up, it will not be 1. Hence, we have to normalize the weight. we have done the same thing here. We will add them, divide each new weight with the total value. Finally, the normalized weights will be something like this. If you add them together, it will be more or less 1. Finally, we create ranges of each records and use random function to choose the samples for our next week learner. That means we are preparing the data set for our next model. This will help us to provide more weightage to the misclassified records. Let's see why. While creating the range will be something like this. Initial record will have 0 to 0.13. For next range, we will add 0.13 here. Hence, 0.13 to 0.26 will be the range. Similarly, we will add 0.13 again and we will get 0.26 to 0.39. Notice here, the misclassified row has a larger range, which helps us to upsample the misclassified row for our next model. Let's say our random function generates 5 different values. Why we are generating 5 values? Because we have 5 entries in our dataset. We are generating 5 random values between 0 and 1. Let's assume we get the values something like this: 0.1, 0.4, 0.6, 0.8, 0.99. For all these 3 random values, our misclassified row will be picked up. So in our next data set, the misclassified rows count will be more and the correctly classified sample count will be less. In this way, we are upsampling the misclassified rows. That means whatever misclassification happened in model 1 will be fed into model 2. The misclassifications of model 2 will be fed into model 3 because we are increasing the weightage of the rows where our previous model performed badly. Hope you have realized how AdaBoost works internally. Let's understand the takeaway from this session. In this session, we have discussed about AdaBoost, which is nothing but a model based on boosting technique of ensemble learning. We have discussed about the advantages and disadvantages of AdaBoost model. Now we know how we can implement AdaBoost in our Python code using sklearn library. We have written some code in Jupyter notebook as well in order to classify the iris flower species. Finally, we have gone through each and every steps of AdaBoost model and understood the important mathematical equations for it. Hope you have enjoyed this session. Thanks a lot for watching this video.